Welcome back everybody. In today's video, we're diving into the hack the box easy machine called Inject. This machine is a really interesting vulnerability chain that I believe is just perfect for beginner penetration testers and ethical hackers. And I'm going to be walking you through the steps on how to exploit it for a remote code execution. Now, if you've seen my last video on the LFI, on the Try Hack Me room, you know that this is going to be about local file inclusion, Path Traversal, and as well as a SpringBoot vulnerability that we will dive into that eventually leads us to remote code execution, an RCE for our Foothold. And the fun doesn't stop there. The root step involves abusing a cron job running an Ansible automation framework. Now, if you're new here, I'm Alupulu, a cyber enthusiast who loves CDF challenges, researching vulnerabilities, and just everything hacking. So make sure to stick around and let's get started. All right, so let's go ahead and throw that IP address into our host file so that we don't have to remember the IP address going forward. We can just remember the name of it. So here is the IP address from hack the box, and we are assigning it to the name of the machine, which is Inject, and we are putting the .htb for .com, but instead we're using the .htb for hack the box. So now we can actually reference it that way. So we'll go ahead and save it, exit out of it, and clear the screen. And now we can go ahead and ping inject.htb and see if we can get a response, meaning have we set up our OpenVPN correctly? And in this case, we're getting back some bits, and that means we're able to reach it. So we can go on and start doing our Recon search now. So we're going to do nmap with the P flag for all the 65,000 or so ports for the IP address at inject.htb. And we're going to run it on a min rate of 10,000 because we want this to be a quick scan to see what ports are open. And we're really not worried about being detected or being flagged by somebody because this is a hack the box machine. So here we go, finishes under 8 seconds, and it comes back with 2 ports being open, 22 TCP for open for SSH. So that's awesome. That means that there may be a possibility if we get some credentials in the future that we can probably SSH into the machine, unless it's not allowing us to do that with a password, meaning that we need an authorized key. And the other thing is an 80 or 8080 is an HTTP proxy. So we're not getting the typical 80 port, but we're getting an 8080 for the HTTP. So that's interesting. So let's go ahead and do another nmap scan, and we want to be a little bit more specific. In this case, we want to just target those 2 ports. We want to use nmap's scripts. In this case, the scripts that we're using are right here, the SCV. And instead of doing it this way, sometimes I like running it like this. So these 2 scripts are pretty much telling nmap to use its default scripts to give us a little bit more information on these 2 ports. And we're going to be running it instead of a min rate 10,000. Another way of doing it is doing like a T5. So we're going to let that run, and that's going to do its thing, going to give us a little bit more information. But from here, what I like doing is I'm going to start loading up burp suites. Let's go ahead and start doing that now. Now burp suite is started. We can go ahead and launch Firefox as well. And Firefox and burp suite are pretty much hand in hand, proxying all the requests that go through Firefox into burp suite if I wanted to. And that's through an extension like Foxy Proxy. All right, so let's go back to our nmap scan, and here it is. So we're getting some information on the SSH. It looks pretty up to date. It is on Ubuntu Linux. Let's see here. And the other thing is we're getting 8080 TCP information. It is also on the Linux. So that's interesting. Now we can actually go ahead and take a look at the website and see what we're working. If we were to go to this without the port 8080 at the end, the typical 80, we're going to get this error, right? We're going to get the failed to connect on port 80. And this is typical, but our nmap scan discovered that there is an HTTP proxy for the website, and it's on 8080. So we do need to make sure to throw that information into the browser so we can actually access the web app. And let's take a look. It looks like this is the website, and it is a Zod cloud. So store, share, and collaborate on files and folders from your mobile device tablet. So it looks like it's an online cloud provider. So that's pretty cool. 0 month free. Okay, awesome. So typically what I like doing here is I'll go through, right click, and go through the page source and try to see if there's any hidden information in there, and see if there's anything built out. And I've already done that, but what I'm noticing here is there is an upload button. So let's go ahead and click that. And that should be a huge red flag whenever you see something like upload or anything that you can kind of interact with. In this case, when we click the upload, it redirected us to the upload page. No surprise there. But the one thing that pops up is now we get an ability to upload something to the web app. So that's a huge flag for me, because that is a potential attack vector. Now we need to dive in and see exactly what this is working with. So let's go ahead and go back into Burp Suite, and we'll go into the top left here into proxy, and we want to start intercepting all the requests that our browser through Firefox is going through. So we're going to turn on intercept. That means everything on Firefox is going to start going through Burp Suite, and we can take a look at the request and say, hey, we want to make some modifications, or hey, this looks good. Let's go ahead and send this to the web app. All right. So here it says no file selected. So let's go ahead and select a file. I'm just going to do a very simple image, right? Here is my image, Tifa from Final Fantasy VII. So I'm going to go ahead and upload that. And there is our request. So it's capturing that request here, which is a post request to the endpoint for upload. And here is the host, right? The Inject HTB on port 8080. Here is our user agent and a bunch of other information that you don't have to worry about. But you can see here the form data is a file, and here we're getting the file image. So Neospring Tifa small. So that's what I'm essentially, that's the file name that I'm uploading, and the content type is an image PNG. So what I'm trying to do here is I'm kind of trying to figure out where is this being uploaded so we can get that URL link, because if we can upload an image, maybe we can potentially upload a reverse shell. And if we can find out where that file is being saved, we can access that file and get that reverse shell. But here is the PNG information. So this is all the information, kind of the bits between or behind the image itself. And it's a lot of information. I don't have to really worry about it. What I care about is actually just sending this to Repeater. And what Repeater is if I want to make changes to this request and send it multiple times, that's exactly what Repeater does. So I'm going to send that to Repeater just so I have it. I'm not going to mess with it, but I'm going to go ahead and forward this and then go back into the browser. And it looks like that was uploaded. So that was awesome. I'm going to go ahead and turn off Firefox or intercept, because Firefox loves to start reaching out to its like plugins and all these other things. All right. So we got the uploaded successful. So it's saying it's uploaded and it gives us the link. And if you look here on the bottom left, it's showing us where that link is. So that's not being obfuscated in any way. So that's awesome. So that means that maybe if we upload something malicious, we can actually get to the link and trigger that reverse shell. But let's go back into Burp Suite, turn intercept on. And let's go ahead and click this link. So we have this in our Burp Suite. So now we're getting a request or a get request to the endpoint show image. And it's doing a question mark for image, and it's requesting that one image. So I think that's a PHP parameter for show image, and it's requesting image. Okay, so I'm going to go ahead and right click this and send that to Repeater. So I have that. Because this is something we're going to play around with. And I'm going to forward that, And let's take a look at what happened. Okay, there it is. So there is my image. It was uploaded successfully. And here is the URL for that image. So that's awesome. So from here, let's go back into Burp Suite and go into repeater and see if we can send that again and what happens. Okay, we're getting back at 200. Okay, we could also render it in here. Okay, awesome. So if you watched my last video, you kind of know what the theme for this video is, right? It's LFI. So let's go ahead and start testing if this web app has an LFI vulnerability or not. If it doesn't, then that's probably not our attack vector, and I duped you. And maybe we need to go down the RCE file upload type of attack vector. But let's try it, because what I'm noticing here is the same thing that we saw in the last video for the lo-fi from the try hack me, is that we're getting a get request for this parameter, the show image parameter, followed by that question mark, and it's requesting the image and it's pulling this particular image. So what I'm assuming then is there may be a bunch of different images and it's still using the show image parameter to request those images. So what we want to see is can we change this and see if there's any type of sanitation, validation on the back end in regards to trying to access some internal files that we shouldn't be allowed to access. So the typical is, like we did in the last video, the etc password. So let's go ahead and send that. Let's take a look at that. And we're getting back HTTP 200, HTTP status 500 internal error. Oh no. We can go ahead and render it, and we're getting an internal error. So remember in the last video, what did we do to kind of face this challenge? We started climbing up the directory ladder, right? And to do that is we started doing the dots. And that's kind of going up in directory, trying to get to root. So let's go ahead and start testing that and see if that works. In this case, 500 error again. So we'll do another 2 dots followed by a /, another 500 error. Now, most people would actually take this request and they would actually go maybe into intruder and start throwing a list on this and see, okay, they might have a list on their backend on their Kali Linux attack machine, and it may start going through that list to see, is there an LFI vulnerability or not? But this is an easy box, so I'm sure we don't have to figure out how to bypass any of this. So let's take a look. 1, 2, 3, 4, 5, 6, and then the etc password. So let's go ahead and send that and see if that works. And there we go. So we got back the etc password by going up 6 times in the directory to finally getting to the root directory. And in there, we were able to access the etc password. So that means in this parameter here, the show image parameter, there is no type of sanitation or validation on the server's end. It's just simply letting us take a look at that information and displaying it back to us. So that's awesome. So let's take a look here. We can go ahead and even render this. Okay, maybe it won't render. Let's take a look. So we are getting back a bunch of different information. And what we're looking for here is we're looking for a user. We're looking for a bin bash for users. So we're trying to figure out, okay, here's Frank, trying to figure out what users are we able to discover that we may potentially start our attack vector with. So Frank is showing up. He has a bin bash and he has a home directory. So that's awesome. And so does Phil. He has a home directory and he has access to bin bash. So those are 2 users that I'm going to go ahead and copy and save into my notes, because we can now start looking through with our LFI to see exactly what are we able to access. What do I mean by that? So we were able to access the etc password and we discovered these 2 users. Let's go ahead and instead of etc password, let's go ahead and do home and we'll do Frank. And so we're hoping to uncover Frank's directory. So we're going to let that run. And then, there we go. We were able to access the directory of Frank's, and it comes back with a few other directories, hidden directories of bash history, bash RCE, catch, local, M2, and profile. So the M2 is kind of the thing that stands out. That's typically something I don't usually see on a home user like Frank. So I kind of want to check that out, but that is how we use LFI to kind of discover different things. Now, we can't really trigger an RCE. We can't get Frank's access unless we maybe potentially discover some credentials. And that's what we're hoping for. So let's take a look in the hidden M2 directory and see if we can discover anything in there. All right, and there we go. So we got back and looks like there's only one file in there. It is the settings.xml, and that's pretty promising. I'm hoping there's some type of credentials in there. So let's go ahead and copy that settings.xml and throw that into our LFI as well, so that we can potentially read exactly what is this file. And here we go, we get a 200 OK, and we're getting back in the XML file some credentials for Phil. So that's awesome. And here we go, we get a password for Phil. So that is awesome. And it looks like there is some private key information for SSH and ID DSA. So it looks like we may be able to potentially SSH as well. So let's go ahead, and I'm going to open up my clipboard manager because I do want to copy that. I want to copy that password. And now that we have that password, let's see if we can, let's see, go into hackthebox inject, clear it. And now I want to SSH as Phil into inject.htb, right? And let's try that. Yes. Okay, enter in that password. Password denied. Let's take a look at it. Okay, so I have it in there. Let's try one more time. No? Is it not Phil's password? We're not able to access SSH with that one password. So it means that we need to start looking for other attack vectors then. Okay, let's go back into Perp Suite. All right, since we tried Frank, let's go ahead and see if there's anything in Phil. And let's take a look. So now we're trying to get the contents of Phil's directory and information. All right, there we go. So we got back Phil's information, and I'm not seeing any like SSH in directories, but we are noticing the user.txt flag. Now I'm assuming if I try doing like the user.txt flag and try reading this, that I'm probably not going to be able to, because most likely we are accessing the LFI through the www data. And I'm assuming user.txt is probably assigned to Phil. So we don't have access permission wise to user flag. But let's go ahead and run it and see if we can access it or not. And there we go. So we did get back a 200 OK, but we're not getting any information. So it looks like, yes, we don't have access to it. So from here, the other opportunity, or I guess attack vector that we need to go down is probably going down the var www rabbit hole, right? Because we are in the app. So let's take a look to see if there's any configuration files, any XML files, or anything in the www web app folder. So let's go ahead and send that. All right, and here we go. We get two directories in the var www, and no surprise, the web app. So we now know what that is called. It's called web app. And we're going to take a look at what is inside web app before we start looking down into the HTML. So I'm going to send that, and let's take a look to see what files are in this directory. All right, so we get a number of different files here. The thing that stands out is whenever I see XML, so that's kind of standing out to me. But I do recommend kind of going through, seeing what all these files and informations are. But let's go ahead, and since we're seeing an XML file, I kind of want to take a look at that. So let's go ahead and send that and see what this is. Okay, So it's coming back with XML file. Let's take a look. So what I'm noticing here is artifact ID, SpringBoot starter, SpringBoot DevTools, Spring Cloud, SpringBoot. Okay, so a bunch of SpringBoot and Spring Cloud things. And it looks like it's some type of framework. So what do we do from here? Let's go ahead and start Googling. Before we start Googling, we need to figure out what version is. So let's look here. And what I'm noticing here is there is a version, a 3.2.2 for cloud, for Spring Cloud Function. And this is a framework with cloud. And I'm noticing Spring Cloud 3.222. So let's go ahead and go into now Firefox. From here, we'll do, what was it? Spring Cloud 3.2.2 vulnerability. And let's take a look and see what pops up. Let's see. I think Exploit DB is a pretty good one. They usually have some solid information. All right, here we go. So we're getting a Spring Cloud 3.2.2 remote code execution, RCE. So that's pretty promising. That is something we want to get. And let's take a look at this proof of concept. I'm assuming this is a proof of concept. Okay. All right, so it's importing a bunch of things. Okay, and it looks like it's targeting the function router endpoint. HTTP function router. Okay, so we want to do that. Print, that's just printing. And here we're getting a header and it looks like, okay. So it's using a Sprout Cloud function routing expression, doing some Java thing, assuming it's Java, built on Java. And it looks like it's executing a command. So we can go ahead. This looks pretty promising. So I guess what I'm going to do is I'm going to actually copy this entire thing right here. And we want to target the endpoint function router. Okay, so that's in my notes. So let's go back. Let's see. Let's do that. HTTP inject. And then we want to do function router. And before we do that, let's go back into our burp suite because we want to capture this request. So what we're trying to do is we're trying to build out this payload in burp suite. So we will go to proxy, start turning intercept on, send that, and there it is. So it's doing a get request for that. We can right click, send that repeater. And again, repeater is the tool that we use to kind of change the request that we want to and make continuous sends for that. We can go ahead and send that and then go into repeater. And let's take a look at what that does where we just send it normally. And it comes back with a 500 internal error for a get request. Okay. So let's figure this out now. So I'm seeing data here. So it's an RCE. We can't use a get request. So we do need to change it to a post request. And I am noticing data. So data is typically what we do with a post request. We're going to start making post request. So let's try that. So what I'm going to do is I'm going to right click and instead of get, we're going to change request method to a post request method. And that's going to change that. And if we send that, we're still probably going to get a 500 internal error. But let's go look at the proof of concept and see exactly what it's doing. So we have the first part down, right? The URL. So that's done. And it looks like they're adding the command here and they're doing some type of ping. So for their proof of concept, they're adding a ping and they're putting it in the exec function. We don't want to do that. We kind of wanted to get the RCE ourselves. So let's go back in here, and we notice here it is headers. So that means it's going to be not in the data, right? Because the data is empty here. It's going to actually be injecting into the header. So let's go ahead and paste that in there. And let's change this so I can get it. Okay. So we're going to change this around a little bit. Let's clean this up. Okay. I think that will work. Now we do want to change here for instead of exec, what we want to do is we want to get our reverse shell here in this exec function. So let's go into our, because it looks like they're pinging. That means that there's probably a possibility for the web app to reach out to our server, right? Because it doesn't have internet. So we need to be able to set up a bash script, a reverse shell on our local system so that the web app can reach out to it. So let's go ahead and do that. All right, from here, I'm going to open up a new window, cd into inject, and I've already, let me take a look. I've already created a reverse shell in very simple bash script. Here it is, and here is the IP address, and you can see here in the top right, my IP address followed by the port. So I have the rev shell already made. And for you, if you want to figure out how to make that, you just go revshells.com. And here we go. You have a bunch of different rev shells. All you need to do is enter in your information here, 14170, put your port number, and it's going to update this. And you can go ahead and figure out what, which one you want to do. All right, so going back here, so now we have our rev shell. Let's go ahead and run a Python 3 HTTP server on port 8000. And what that means is we're essentially allowing the machine to access this folder. And in this folder, there is the revshell.sh, right? The bash script. So that is open. Let's go ahead and go back into Burp Suite, go into the repeater. Now we want to go ahead and change this and start doing a curl command to our Python server for the reverse shell. So we'll do curl HTTP, and then we'll put in the IP address. And then I believe it was under port 8000 that I was running that under, and it was named rev shell. And from here, we also want to save this output into the, let's see, Frank folder. I think that looks good. And we want to save it as the same file. So we're curling the request. We're curling this one file here, the reverse shell, and we're saving it in the home directory for Frank as the rev shell. Because we know with our LFI, we're able to access the directory of Frank. So what we're hoping for is this command, this RCE, is going to be able to upload it, and then we're going to be able to maybe trigger it again. So let's go ahead and send it that and see what happens. And we do get back a 500 error, but let's go back into our request here that we were using for the LFI, the show image request here. And then let's see, let's go back. What do we want to do? We want to go into the Frank, right? And we want to see if we can access this revshell.sh. Now, before I actually launch this, let's go into, actually, we can just see if it actually worked. So let's send that, and that's going to take its second. But while that's doing that, let's go ahead and open up a new window now. And we want to cd into hackthebox inject, and we do want to run the netcat for the 1234, because remember the rev.sh, the bash script that we uploaded onto the server, is going to be reaching out to our netcat on the port 1234. So we do need to run netcat 1234. And now we go back to burp and let's see if that finished. Okay, there we go. So it looks like that didn't work out. So we're not seeing that being executed. We're not seeing a rev.shell in Frank. So let's go back into our payload and let's see, where did we mess up here? So maybe these little quotations or apostrophes, let's try it that way. So I removed those two single quotes around it because I'm assuming that messed up with it. And I think we do leave that in there for the curl. Okay, let's send that. And let's try that one more time. And there we go. So that time, by removing those single quotes around that, it's showing up. The rev shell is being successfully sent. And it is being uploaded in the home Frank files. So now that we have that, and we know our netcat is running on 1234, let's go ahead and change this initial request. Instead of curling it, we want to execute that rev shell so that we can get a connection back. And to do that, we're going to simply delete this entire script that we have in the exec, and we're going to do bash, and now we're going to do bash home, what was it, frank.rev shell, just like that. And so we're essentially using this payload, this little Spring Cloud function, to execute the bash with bash for the file, the rev shell. So the web app, the www data, through this payload is going to execute the rev shell on the file in Frank's folder, and it's going to reach out back to us, and that's how we're going to get our reverse shell. So let's go ahead and send that and see if that worked. Still getting a 500 error, but there we go. If we do ID, we are Frank, it looks like. So who am I? I am Frank. That is awesome. So we got our RCE that way. So that was pretty cool. From here, we do need to start upgrading our reverse shell. So what I'm going to do is I'm going to open up a new window and do my breakout. And now we're going to simply copy and paste these and update our TTY. All right, there we go. So we are Frank now. We can clear it. We can ls. Let's see, what can we do now? So can we cd into home? Can we cd into fill? Can we cat? Okay, so we don't have permission for the user flag just yet. We are Frank, but let's figure out now. Remember, we did get some credentials, and whenever we have credentials, we know reuse password is really common. So let's go ahead and try to see if we can maybe sue into something, sue into fill, because remember the credentials are for fill. So let's try see. Okay, so we were able to get Phil's access with the credentials that we found by getting the RCE into Frank and then suing into Phil. So that's awesome. Now that we are Phil, we can go ahead and cat the user flag, and there is the user flag. So that's awesome. So I'm going to clear it, and now let's try the typical sudo out to see. And we're going to put in our password. And it looks like, sorry, user Phil may not be able to run sudo on the local host. So that sucks. So we've already pivoted from Frank into Phil. So we need to figure out where our next pivot is. I don't think there's any other users. I think we need to start figuring out how to get into the root user now. So let's start doing that now. Now my typical go-to for this is if I don't have any other pivots left to me, like there's no other users that I can go into, like if I go into CD home, if I ls home, there's only Frank and Phil, right? So there's no other users that we can pivot into. We've already gotten our RCE into Phil, and then we've our RCE into Frank, and then we privileged or pivoted into Phil with the credentials that we were able to get. So from here, we know, okay, there's no more pivot in, and we don't have sudo L. My go-to is then running linpies. So you can go ahead and download linpies on here and run that. But for the sake of the video, so it doesn't get too lengthy, this is what we're looking for. We're looking for this playbook. So here we go. It is in the opt automation. And if we do an ls for opt automation, we notice here that it is run by root and staff. So tasks, it has the ability to be run by staff. Now, if we did an ID, we noticed Phil is actually part of the staff group. So that means that we have the ability to make some edits in the task files. So let's start doing that now. So I'm going to cd into opt automation, and let's take a look to see exactly what's in there. There is the task files. So there is a playbook. So I'm going to clear it, cat the playbook, and let's take a look. So it looks like it's a very simple file. And it is a .yml. So what is a YML? So that's a YAML file, and that's usually used in Ansible playbooks. So YAML files typically define a set of tasks to be executed either on one or more remote hosts. Now, playbooks are a great way to automate tasks such as configuration management or application deployments. Now, we've already found that the opt automation folder was owned by root and staff, and we know Phil is part of the group staff. That means Phil has perms to read, write, and execute the files in the task directory. And we have discovered by catting the playbook.1 YAML file, we essentially can maybe alter this file and see if we can get a reverse shell, or at least privilege escalate into root. So what I'm going to do first is I'm going to see if I can actually change it. I'm probably not going to be able to. So let's go ahead and nano it. And yeah, that's right. So it's not writable. So we can't initially change this playbook. But what we can do is we can go ahead and copy this entire thing, because we want to pretty much structure the payload the same way that we have the playbook, right? So I'm going to copy that. And what I'm going to do now is I'm just going to simply make my own playbook. So from here, what I'm going to do is I'm going to simply just nano neo.yml. And here we go. And I'm going to paste in the payload that I'm doing. So we're essentially just tweaking that playbook one a little bit. And what I'm doing here is I'm doing the host localhost, and I've removed all the other things. But what I want to do here is copy the bin bash and throw it in to the temp folder under Neo, and as well as chmod the temp file for Neo, so that we can privilege escalate into Neo. So I'm going to save that and exit. And if I do run the playbook, I'm assuming I probably wouldn't be able to get root access that way. But I think there is a cron job in the back end that's going to run these playbooks. And by doing that, it's running it as root. And that's how we're able to get the new Neo file that we made a copy of bin bash as root. But in there is the chmod, so giving us ability to access it. So let's take a look and see if it ran it. I'm going to ls la the temp file, And let's see, so we're not seeing anything in there just yet. And there we go. So it did pop up, the cron job did it. And if we LSLA neo, it is a root, and there are the permissions. So that is taking effect through it. So from here, let's go ahead and run temp neo p, and there we go. So we can go ahead and cd into root, and then we can cat the root flag, and there we go. So I'm going to copy that, throw that in, and that is essentially it for this machine. I hope you enjoyed it. It was a fun machine to dive into, especially learning that whole LFI tree and even pairing it with that RCE. I think those two being chained together is something that you're going to start seeing a lot more going forward. They are great tools in your arsenal. If you enjoyed this video, go ahead and hit that like button, subscribe, and I'll see you guys in the next video. And if you have any questions, feel free to throw them in the comment section below.